Hi, welcome to the Shiko Math Lab um, mathematical statistics problem solving sessions. So today we're going to solve a problem here is if X has a chi-square distribution with degrees freedom V, I want to find the expected value 1 over X. And the reason why we try to solve these problems here, and the first things we're going to introduce the why we care about the expected value of the 1 over X here. Okay, so let's go to the whiteboard here. Okay, so the whiteboard, okay. So the first thing is here, you wonder why we care about it. All right. So the reason why we care about it is, we know the t distributions, right? So we know the t distribution is a typical, the way we defined as is a ratio of the z. Z is a standard normal. And let's say here, here is a w over the v's here. So let's say here, this w's here is the chi-square distribution with degrees freedom v. So, and also we know the z's here is the standardized normal 0, 1s, right? So, the reason why we want to calculate the 1 over x, the 1 over x, if x is a chi-square, the reason why is it will be very useful when we try to find the mean and the variance of the t's here, right? So we can find the mean of the t and the variance of the t, we will need like e the t square minus et the squares here. So the et the square, so if you take a look at the t squares here, it will be z square and w over v here. So you see the reason why is here, right? Because the w is on the bottoms here. So you want to find the expected value. If I know what is 1 of w, and then I'd be able to easily and find the variance of t. So let's just, the reason why, I choose to do these problems here. Okay, so let's take a look here, right? Let's go to the next pages here. So if x is a chi-square with degrees freedom v's here. Now I want to find the expected value 1 over x here. Okay, so now let's see here. So the first things here, let's try to write if x is a chi-square, so what is the chi-square distribution, the PDF here, right? So the chi-square's PDF, this is 1 over 2 to the v over what? V over 2. Then this is a gamma function, v over 2 here, all right? And then here, this is x v over 2, right? So this is the v over 2 minus 1. Then we have the exponential negative x over 2 here. Okay, so now I'm going to find the expected value 1 over x. So it will just be, so from the 0 to infinity, I put the PDF here. So this is 2, the v over 2, the gamma v over 2, and x to v over 2 minus 1, and the e to the minus x over 2 times what? X to the negative 1 dx here. Okay, so the things here, the technique we're going to use is we try to manipulate what is inside here to make it's a PDF. Now, when you integrate the whole domain, it will be ones, right? Okay, so let's take a look here, right? So let's combine these two terms. This is x minus v over 2 minus 1 and the x minus 1 here. So let's try to combine these two. Then let's start to manipulate the constant to see how do we can find it. So this is V over 2. This is a gamma V over 2. All right. So then this is what? This is V over 2 minus 2, right? So this will be the V over 2, okay, minus 1, right? Okay. Then I still have e to the negative x over 2. So nothing else changes here. Okay. So now let's take a look, move the this constants out. Okay, so I will move this constants out. So this will be 1 over 2, the V over 2. And this is gamma V over 2. Okay, so now this one's here is 0 to infinity. Okay, so now in here, let's take a look. Okay, so for this ones here, this is V over 2 minus 1. All right, so then if you combine these two will become what is V minus 2 over 2, right? So this will be the V minus 2 over 2 here, and then the minus 1 here. So let's treat this number is like my new V star, okay? Okay, so so this one would be the V star over 2. So the whole this terms change to the x, the V star over 2 minus 1. Okay, so you see that looks very, so we want to manipulate those constants and then make it to be a PDF here. Okay, so how do I manipulate it here? So by using the the chi-square. So this is 2 of the V over 2. So what I should have here, I should have 2, the V stars, right? So what is V star? V star is V minus 2, right? So I will have 2 to the V star. So it's 2 to the V minus 2. All right. So right, so now the next thing here is a gamma function. So V, so I need to replace V with V star. So what is V star? Is V minus 2 over 2, see here. Okay, and then in here, I cannot just divide by some constants. So I need to adjust it. So this one here, I need to times it back. So this is V minus 2 over 2. And this is a gamma function, V minus 2 over 2, right? So I basically just, just back. And then in here, this will be my x, right? V over 2 minus over 2 minus 1 e to the what? X over 2 dx. Okay, so then in here you see this one's here is what? It's the PDF, right? So this is the PDF of another, another chi-square with degrees freedom, a V minus 2 here. So I know if you integrate the whole PDF, what is this one going to become to? This one is become to 1. So, right, so this inside this PDF is becoming another chi-square with V minus 2. Right, so this would be the chi-square distribution with V minus 2. So that's why when you integrate over the whole domain, it's 1. So now I have this one left here. So I have this is 2. So this is 2, the V minus 2, right? So you can say the V over 2 minus 1. And then this one here is gamma, right? So the V minus 2 over 2. And this is 2 the V minus 2. So then here I'm going to use gamma functions property. So I know for the gamma functions here, right? So gamma alpha, you can write is the alpha minus 1 times gamma alpha minus 1 here, right? So now you can treat this is your what? You can treat V over 2 is your alpha, right? So you will be the V over 2. So this will be V over 2 minus 1. Then the gamma, right? The V over 2 minus 1. So I know the V minus 2, this one's here. I know this one's here is just become what? This one just become like a gamma to the V minus 2 here. Okay, so good, right? So we have a lot of things we can cancel. So this one cancel, this one cancel. Then V over 2 cancel, V over 2 cancel here, right? All right, so now this is, we have 1, the 2 to the negative 1 power. So the top will, what left on the top is 2 to the negative 1 power. What left on the bottom is this V over 2 minus 1. So V over 2 minus 1. Okay, so let's just use algebra to simplify it. So this is 1 can move to here. Then V over 2 minus 1. So this will be 2, the V minus 2 here, right? So now we can do it again. So it's 1, the cancel. So this is what? This is 1 over V minus 2. Right, so that's what I can prove I can show the expected value of 1 over x is equal to 1 over v over 2 here. Of course, in here, the v minus 2 has to be greater than 0, right? So that's why the v has to be a degrees freedom greater than 2 here, right? So that's what is the expected value of the 1 over x if the x is a chi-square. So remember the reason why and the high motivations here we want to do is because we want to be able to use this fact to try to help us to solve the variance of the t-distribution will be a lot easier by using this factor here. All right, that's it. Okay, then hope you find this video is helpful, and so hope you enjoyed it, and hope it's help you find it's helpful here. All right. Okay. Nice talk to you, and talk to you in our next problem solving sections here. Okay. Bye bye.